Welcome back to part two. We are now going to look at equations of quadratic form. And what that means is if we are starting with our solutions, can we find the equation that we started with? So if we think back to the steps of solving by factoring, we factor, which means we get our double parentheses, we set each of those parentheses equal to 0, and we work until x is by itself. So if I'm going to do those steps in reverse order, what that means is I need to take these two solutions and rework them into equations that are equivalent to 0. So that would mean I would subtract 1 and subtract 2. So essentially, these were my two factors from my factored form, x minus 2 and x minus 1. So if I want to put that back in quadratic form, I would need to FOIL this. So x squared minus 2x minus x plus 2, combine my like terms in the middle, and x squared minus 3x plus 2 would be the quadratic equation that I started with. B is similar. I've got these two equations that I need to put back in the form equal to 0, so I'm going to add 2 for the first one. So x plus 2, now I'm at 0. For the other one, it's not as easy as just subtracting 1/4 because remember, we don't keep fractions in our factored form. So what I need to do is clear the fraction by multiplying by my denominator. So if 4x is equal to 1, then I would subtract 1, and 4x minus 1 is my second factor. So this would have meant x plus 2 and 4x minus 1 were my two factors. So if I were to FOIL this back out, I would have 4x squared minus x plus 8x minus 2. Combining those middle terms, we get 4x squared plus 7x minus 2. And there's the quadratic equation that I started with. Now we can do the same thing with irrational solutions. So if I have 3 plus the square root of 2 and 3 minus the square root of 2, that's the same thing as 3 plus or minus root 2, which typically what we would see at the end of completing the square. So if we think backwards from the steps of completing the square, well, my last step was always moving over whatever was next to x. So if I put that back by subtraction, I have x plus 3 equals plus or minus the square root of 2. Well, at this step, this meant I had square rooted both sides. So to undo that, I'm going to square both. And if you're squaring a binomial, remember that means you're multiplying it by itself, so you are FOILing. So over here, I'm going to have x squared minus 6x plus 9, and that's going to be equal to 2. So the final thing I need to do here is move the 2 back over, and x squared minus 6x plus 7 would be the equation I started with. We can also do this with imaginary solutions. So on D, this one's very similar to C. I'm going to start first by moving that 3 back over. And then I need to think about what does this plus or minus 6i mean? This is how we were representing our imaginary solution, but what did 6i really come from? Well, that came from the square root of negative 36. The I was because it was imaginary. The 6 was able to come out because 36 is a perfect square. So this means that x minus 3 is equal to plus or minus the square root of negative 36. Now I need to undo that square root by squaring both sides. Again, FOILing on the left. And on the right, I now have negative 36. So after I add that back, I have x squared minus 6x plus 45. And last but not least, we have 1 plus 2i and 1 minus 2i. Again, that would be the same as having 1 plus or minus 2i, which is kind of what we had been working with previously. So I'm going to keep it in that same form. I'm going to move the 1 back over, and x minus 1 equals plus or minus 2i. And remembering 2i would have come from the square root of negative 4. The I being because this is an imaginary solution, and 2 was able to come out because 4 is a perfect square. So x minus 1 is equal to plus or minus the square root of negative 4. Now I can square both sides. And FOILing on the left, I'm going to get x squared minus 2x plus 1. And on the right, we have negative 4. So I can move the 4 to the left, and we have x squared minus 2x plus 5. One last thing we're going to talk about today, and this is going to be a blank page on your back side, and we are going to add something in. So if you need to pause this to write that down, go ahead. But we have multiple forms for a quadratic, and right now we're going to focus on standard and vertex. So standard is what we've been working with for the most part here, ax squared plus bx plus c. Vertex, a times x minus h squared plus k, tells us where our vertex is at, hk. Now in the fall, we learned how to go between these two forms by using the vertex formula. Remember, h was negative b over 2a. You would plug that in to find your k value. Well, we can also go from standard to vertex form using completing the square, and it's actually faster when you do completing the square. So that's what we're going to look at now. So I've got this first example here. So if I was going to start completing my square, first I would need an equal sign here, and I want to move my constant 5 over. So it's now negative. And then what completes my square? Well, half of negative 8 is negative 4. Negative 4 squared is 16. So I need to add that to both sides. So over here, I have x minus 4 squared, and that is equal to 11. Now, if we were solving, this is where we would square root both sides and keep simplifying, but we're not solving. Remember, we're putting it in vertex form. So if I look at what I have here and what vertex form is, the difference and the thing that I still need to correct is that my k value, 11 essentially, is on the wrong side. So I can correct that by subtracting, and my quadratic equation will be x minus 4 squared minus 11. So what that would mean here is I have a vertex at 4, negative 11. Okay, let's get some more practice in here and doing that again on B. I need an equal sign to move something to, so I'm going to move the 4 over. And then we got a good old odd number here, so half of negative 9 is going to be negative 9 over 2. When I square that, I get 81 over 4. So that is what I'm going to add to both sides. X minus 9 over 2 squared is going to be, I need a common denominator here, so I'm going to make that 4. So this will be 16 over 4. So we have 16 and 81, that's going to be 97 over 4. And again, I'm not solving, I want vertex form. So what I'm going to do is move that 97 over 4 to the other side. And I have that y equals x minus 9 over 2 squared minus 97 over 4. And that would mean our vertex is at 9 over 2, negative 97 over 4. So for both of those, our a value is 1. What happens when a is not 1? That's what we are going to look at for the final part of our lesson today. Again, I need this equal to 0, and I'm going to move my constant 7 over. And if I was solving, this is where I would divide by my a value. But in vertex form, I need to keep a. I need it in my equation. So instead of dividing it, I am going to look here, and I have 8 and 16. That means I can factor out an 8. So what would that give me left over? X squared plus 2x. And this is where I'm going to create my perfect square. Half of 2 is 1. 1 squared is 1. Now for equivalence, I need to add whatever on the left to the right. But recall, this is not just 1. If I were to distribute the 8 back out, this is actually 8. So I need to add 8 to both sides. So what that means over here is I have 8 times x plus 1 squared equals, this is now 1. And to put it in my final form for vertex, I need to subtract that 1. And I have 8 times x plus 1 squared minus 1. And this would mean we have a vertex at negative 1, negative 1. Okay, last but not least, we're going to do the same thing. I need an equal sign, and I'm going to move my constant out of the way. So we have 4x squared plus 56x equals negative 202. Again, I'm not going to divide by a because I need it in my equation, so I'm just going to factor it out instead. And this is going to give me x squared plus 14x. And then what completes this square? Well, half of 14 is 7. 7 squared is 49. And again, for equivalence, whatever I'm adding in on the left, I need to add on the right. And this is not just 49, this is 49 times 4, which is 196. So on the left side I have 4 times x plus 7 squared, and that is equal to -6. Last thing we need to take care of is moving that k value back over. So we have 4 times x plus 7 squared plus 6, which means our vertex is at -7, 6. And that concludes our day 2 lesson on solving quadratic equations.